Hello friends, so in today's question, two cubes of masses m1 and m2 be on two frictionless slopes of the block A which rests on a horizontal table. The cubes are connected by string which passes over pulley as shown in the figure. To what horizontal force F should the whole system, the block and the cube, be subjected so that cubes do not slide down the planes, and what is the tension of a string in this situation? This is the main block A. It has two blocks m1 and m2 connected by string, and they have angle of alpha is there and angle of beta is there with respect to horizontal of the slope of the block A, and it is subject to a force F towards the right, and we have to find out what is the force and what will be the tension in the string so that cubes do not slide down the plane. So one of the condition should be satisfied by these cubes m1 and m2, that they are not sliding down the plane, is that the downward force should be balanced by the upward force. That will be the basic concept behind it. Okay. So what we are going to do, we are going to draw free body diagram for m1 and m2, and then we are going to find out further solution for that. So free body diagram for m1, for cube m1, okay. Let us suppose this is the slope and it is making an alpha angle. This is our m1. So first of all, it is going to have mg, m1g in the downward direction, and there will be tension T with help of a string in the upward direction. Now this m1g rather, can be divided into two parts, components. This will be angle or alpha. So this will be our m1g sin alpha, and this will be m1g cos alpha. So there will be also a pseudo force that will be acting in this direction, and its value will be equal to m1f. Now this m1f can be divided into two components. First one will be in this direction and second will be in this direction. So this is our angle alpha. So we are going to get this as m1f cos of alpha, and towards here it will be m1f sin alpha, and there will be also normal acting in this direction. Let us call this as n1. So it is said that there is no, do not slide the plane. Okay, so we can draw from this free body diagram, we can say that m1g sin alpha is equal to T plus m1f cos alpha. Let us call this equation 1, and this is in the direction of the motion. Okay, so as rather we can say, and we can also use the vertical part also, like n1 will be equal to m1g cos alpha plus m1f sin alpha, but it is not much required in the further solution, so we are only going to consider the part which is can take part in the motion. Okay, so we can say that this is for along the direction of motion, and direction of motion obviously will be in this direction, which is not going to take place, yet it is said that do not slide down the planes, okay, along the direction of motion. Now the second, we draw free body diagram for M2. Free body diagram for cube M2. Now this slope and this angle is given as beta, and we have this is our M2. So the force, first of all, which is acting in downward direction will be our M2G, and there will be tension T in this direction. Now this M2G can be divided into two parts. This will be our beta, so we get this as M2G cos of beta, and along this axis it will be M2G sin of beta, and there will be also a pseudo force M2F, which can be also divided into two parts, this as well as in this direction. So we have here M2, this will be our beta, so M2F cos of beta, and this will be M2F sin of beta, and obviously there will be normal, but we are not to consider because we are only considering the along the direction of the motion. So from free body diagram we can say that M2F cos beta is equal to T plus M2G sin beta, and let us call this equation number 2. Okay. Subtracting equation 1 and 2, subtracting equation 1 and 2, we are going to get M1G sin alpha minus M2F cos beta is equal to M1F cos alpha minus M2G sin beta. So we are going to combine the like terms for the force F. So you can say that F will be given as M1 cos alpha plus M2 cos beta is equal to M1G sin alpha plus M2G sin beta. So further we get this as F is equal to M1G sin alpha plus M2G sin beta divided by M1 cos alpha plus m2 cos beta. This is the force for which you can say this is the force F in the horizontal direction this is force F in horizontal direction such that the cubes m1 and m2 do not slide. Down the plane. Now we are going to find our tension T. For that we are going to consider the equation 1, okay, and substitute value of F. Considering equation 1, which is given as m1g sin alpha is equal to T plus m1f cos alpha. And let us call this equation number 3. So using equation 3, we get m1g sin alpha is equal to T plus m1. We put the value of F, which is m1g sin alpha plus m2g sin beta divided by m1 cos alpha plus m2 cos beta and whole big multiplied by cos of alpha. Now we open the bracket, you can say this is equal to T plus, get m1 square g sin alpha cos alpha, first term, plus second term we get m1 m2 g sin beta cos alpha divided by m1 cos of alpha plus m2 cos of beta. Now bringing it to the left side, we have T is equal to, we have m1g sin alpha minus m1 square g sin alpha cos alpha plus m1 m2 g sin beta cos alpha divided by m1 cos of alpha plus m2 cos of beta. Now taking LCM, we get this as m1 square g sin alpha cos alpha minus or plus m1 m2 g sin alpha cos beta minus m1 square g sin alpha cos alpha minus m1 m2 g sine beta cos alpha and whole divided by m1 cos alpha plus m2 cos of beta. So this and this term cancels out and we get this as t is equal to and from this we can take m1 m2 g as common. So we write this as m1 m2 g sin alpha cos beta minus sin beta cos alpha divided by 1 in m1 into cos alpha plus m2 cos beta, and this can be written as t is equal to m1 m2 g, and this will be sine of alpha minus beta, and denominator will be our m1 cos alpha plus m2 cos beta. So this is tension in the string. Tension in the string. Thank you.